Hi, good afternoon. Today I would like to talk about the strength of the air molecules, and for this, I would like to take an example of a real life experiment that was conducted in the 17th century. The air molecules are hitting really hard on the surface of the earth, and to emphasize on that point, I have a fact for you. The fact is like this: if you were to if you were to have air within a sphere, a hollow sphere of a diameter of 50 centimeters, and if you were to remove that air within that sphere and put it on the top of a circle of the same diameter 50 centimeters, the push of that air would be as hard as the weight of a 2000 kg rhino. That is a lot of push. So only within that 50 centimeters, that is the amount of push, the weight of a 200 kg rhino. Well, if you don't really believe the push of these air molecules, I have I have another experiment which can demonstrate and make you feel the strength of the billions of air molecules in the Earth's atmosphere. So firstly, even to feel that air pressure, one way to do it is to ensure that there is an object, and normally in the Earth's atmosphere there is air on all sides of that object, and if you were to remove air from one side, there are air molecules hitting on the other side, and one can feel the force of these air molecules if they are leaning, or by putting a certain object or measuring that pressure of the air molecules. And through the real life experiment that I'm going to talk about today, you will clearly get a feel for the strength of the atmospheric pressure. Firstly, as I told you, that vacuum is needed on one side of the object, and on the other side there should be air molecules. So for example, if you take paper, okay, in normal conditions of pressure, and if you were to hang it up, you'll find that the paper does not move. It is in a state of equilibrium, and this is happening because air molecules are from hitting on both the sides of the paper, and therefore the forces from both the sides cancel out roughly, and roughly you'll find that the paper is at rest even when you hang the paper. And now, if you were to take away air from one side, that the what you would see would be different. Let me give you a dramatic experiment now, which was conducted in the 17th century, precisely in 1654, by a German scientist called Otto von Guericke. Initially, from 4th century BC, it was believed that it's not possible to create vacuum, and that was the thinking of Aristotle, and that thinking continued for around 1000 years after that. But in 1650, the, the same German scientist, Otto von Guericke, had invented a vacuum pump. And therefore, from then on, it was understood that vacuum could be created. Before, the belief was nature abhors vacuum. Now, the vacuum could be created with the invention of this vacuum pump in 1650. Now, the German scientist Otto von Guericke, had also wanted to demonstrate the strength of atmosphere. And for this, he did it in a certain location in 1654. Remember, he had invented the vacuum pump in 1650, and he's going to use the same vacuum pump in 1654 to describe or to demonstrate that atmospheric pressure is really strong. So firstly, on May 8th, 1654, what he does is he gets two hemispheres made of thick copper, and then he tries to join them together, and one would form a hollow sphere when they do it, and the diameter of both the hemispheres was 50 centimeters. And these hemispheres, each of them would have a rim at the point of their connection, and it was a flat surface. And this flat surface was smooth, and to make it more smooth, there was grease that was applied on the flat surface, the rims of both the hemisphere, and then both the hemispheres were attached together. And now, what Otto von Guericke had done is he had removed the air from the sphere that was formed on joining the two hemispheres. Remember, the hemispheres were hollow, so the sphere that would be formed would also be hollow. But there is air inside. But with the help of the vacuum pump that he invented in 1650, he was successfully able to remove majority of the air, not the entire air. So it was almost like vacuum inside after he had used his vacuum pump and removed the air. Now what had happened is the two hemispheres, which were joined at their rims merely by the grease as well as the smoothness of the rims, were behaving as if they were stuck together, glued together, as soon as the air was removed from the hollow part of the sphere. Now the real point here is, I would like to talk about the fact that these hemispheres could not be separated even with the help of the horses, which would be tied to these hemispheres in a certain way. There would be two sets of horses, 15 on either side of the hemisphere, and each hemisphere they have a hook, and to this hook was attached a rope, and with the help of the rope, horses were attached on either sides of the hemisphere. There were 15 horses on either side, and the work of these horses was to try to pull as hard as they can so that the hemispheres would fall apart. Firstly, when the horses were not attached, the hemispheres were stuck together, as I told you, immediately after the air was removed from the hollow part of the sphere. And now the horses are trying to pull, and there are 30 horses, 15 on either side. And despite the hardest efforts of these horses, it was not possible to part the two hemispheres. And let me tell you why it was like that. Firstly, there are air molecules that are hitting on the outer surface of both the hemispheres. There are barely any air molecules within the sphere, the hollow sphere, or within the two hemispheres. So therefore, the push from outside, the push of the air molecules from outside could not be countered by a push from air molecules from within the sphere. So therefore, the push from the air molecules outside dominated the push from within the sphere. And therefore, it was possible that the two hemispheres could remain stuck together even after the air was removed from within the hollow sphere. Not even the strength of 30 horses could part the two hemispheres. That is the strength of the pressure, the air molecules, the billions of air molecules in our atmosphere, those molecules that are pushing on the outer surface of the hemispheres. So hopefully I was able to convince you that the atmospheric pressure is really strong. Initially, I've given you a fact saying that if you were to remove the air from a hollow sphere, if there was air in that hollow sphere of 50 centimeters diameter, and if you were to remove it, and if you were to concentrate that air over a circle of 50 centimeter diameter, then the push of this concentrated air onto the earth would be as much as the push of a 2000 kg rhino. And now with the demonstration that German scientists Otto von Guericke had given, you could also feel the kind of push that the billions of minuscule air particles would exert on the outer surface of both the hemispheres. And at that time, after the experiment was conducted, actually the experiment was conducted in Germany at a certain location in the southeastern part of Germany called Bavaria. And there were audience who witnessed what was a spectacle at that time, because no one really thought that vacuum could be created in the first place, and second, no one had an estimation of how strong the atmospheric pressure was. So it was conducted in front of an audience, and the most important of the audience was the Holy Roman Emperor Ferdinand III, who witnessed this spectacle as well. The name of the sphere, this sphere that was formed after joining the two hemispheres, and after the experiment was conducted, the name of the sphere that was formed was named after the hometown of the German scientist Otto von Guericke. The name of the hometown was Magdeburg, so the sphere was called Magdeburg sphere. Hopefully you were able to gauge how strong the atmospheric pressure is after this explanation from the video. Thank you.